All right, people, so we have reached the handy dandy stage of the reciprocal function, aka the rational function. Remember, this one is the one that has these special things called asymptotes. There is an asymptote here at x equals 0, and there is an asymptote here at y equals 0. So notice, remember how the asymptotes are related to the domain and range. If I look at my lovely graphing tool here, the function is 1 over x. Here is my original function. Notice nothing has happened to it. Now, it says here, use my knowledge of transformations to tell me what's going to happen. Well, if I take a second and I decide what this negative, do you think what this negative is going to do? And what do you think this 2 is going to do? Another way to think about it, if this is difficult for you, this is the same thing as negative 2 times 1 over x. So if that's causing you any difficulty, this might help. So I'd like you to think about it for a second. Once you think about it, test out your guess into the software and see how that goes for you. Okay, so if I take a moment here, I realize that there has been a reflection in the x-axis, and I know that there's been a stretch factor by 2. Now, the domain here has stayed the same. X cannot be 0, but x is an element of real numbers. The range has stayed the same. Y cannot be 0, and y is still an element of all real numbers. The reason that these haven't changed is that this function has not moved up or down, left or right. The equation of the vertical asymptote is x equals 0, and the equation of the horizontal asymptote is y equals 0. You'll notice on my diagram, I have 2 key points. I could have taken my 2 key points here from my snazzy graphing software, or I know that one of my original points on the original graph is here at 1, 1. So that comes out to now 1, negative 2, which is this lovely point right here. And if I take my other handy key point, which is negative 1, negative 1, and I again multiply that, I'm going to hit it here at negative 1, positive 2. And then I just simply add in the curve. All right, well, this one looks a lot more like something I know how to do, a little bit more involved, let's say. What I want to do, though, is I want to point out that I don't particularly like the way this one looks. It doesn't look like the others. So for the sake of argument, I'd like you to change it to 1 over x plus 3. And then add 2 at the end. So this 2 that's here in the front, I just want to move it to the end. And I want you to take a moment and think about why I'm asking you to move it to the end. So is there a reason that I'm saying to you move it so that you can think about it a certain way? Once you've done that, I want you to think about what does the plus 3 do that's with the x, and what does the plus 2 that's at the end. So take a moment, think about it, see if you can figure out how to graph it, and then test it out on the software. So if I were to give this a wild guess based on my understanding of transformations, this plus 3 means that it went to the left 3, and this plus 2 means that it went up 2. So if that happened and everything went 3 to the left, that means the asymptote that was at 0 now moves 3 to the left. So my asymptote is now here at x equals negative 3. And if everything went 2 up, that means my horizontal asymptote that was at 0 is at now y equals 2. Because there's no stretch factor here, I can simply understand that my normal point, which is at 1, 1, got transformed also 3 to the left and 2 up. And my other lovely point, which was at negative 1, is now here, 3 to the left and 2 up. I then draw in my lovely curves. I try and hug the asymptotes so I don't actually hit them. I don't actually touch them, but they hug the asymptotes. Now here, if I look at my domain is x is everything but -3. And my range is everything but 2. And here I've already listed the equation of the vertical asymptote, which is x is -3. Notice I put it on my diagram. Please do so. And my horizontal asymptote is y equals 2. So let's go back. Why do you think I asked you to make this change? Why do you think I asked you to move the 2 to the other side? Well, really for the significance of it now looks like everything else that I've done. And because it looks like everything else I've done, my brain can now see, hey, this is something I already know how to do. Again, if I were to use point notation here, this is x comma y, and this would be x minus 3, 3 to the left, and y plus 2, 2 up. If I try my key point of 1, 1, and I move that key point, it now goes to -2, 3. Well, that's true, because that's right here. And if I try another key point, like -1, -1, that becomes -4 and 1. And that's this lovely key point right here. So, if this is the case, have you noticed at this point in time that all the transformations are the same, regardless of the parent function? If not, we've got one more to do.